Hello students, today I am here to teach you the topic defects in solid. It is the topic in the chapter solid state. Earlier this chapter was not the part of syllabus for 12 CBSE. Now again this year it is added in the syllabus. So defects in solid is a very important topic, so that's why I am here with this topic. So first of all, we'll understand the meaning of defect. What does an defect mean? So let us consider a crystalline solid. अपन ने solids में क्या पढ़ा है सारा? Crystalline solids. So crystalline solids में हमेशा क्या होता है? There is regular arrangement of atom or particles or molecules in a crystal lattice. For example, this is a solid. Let it be A plus, B minus, A plus, B minus, A plus, B minus, A plus. कोई भी crystalline solid है ये और इसमें ions present है A plus, B minus, A plus, B minus, A plus. And this is a regular arrangement of ions in this particular lattice. Now, if any ion is missing from here, कोई भी आयन जो है वो अपनी पोजीशन को छोड़ देता है, तो नाउ दिस क्रिस्टल बिकम्स डिफेक्टिव. ये क्रिस्टल कैसा हो गया? डिफेक्टिव हो गया. सो दिस इज व्हाट डज अ डिफेक्ट मीन. एंड डिफेक्ट इज आल्सो नोन एज imperfections. Defects, or we can also call them imperfections in solids. Imperfections, जो भी चीज परफेक्ट नहीं होगी, तो परफेक्ट नहीं है, व्हाट डज इट मीन? इट कंटेन सम डिफेक्ट. तो डिफेक्ट्स मतलब जो भी ऑर्डरली अरेंजमेंट होता है क्रिस्टलाइन सॉलिड्स में, जो लॉन्ग रेंज ऑर्डर क्रिस्टलाइन सॉलिड शो करते हैं, उसमें कुछ डिफेक्ट अराइज हो जाता है, उसमें कुछ चेंज हो जाता है. कोई एटम, पार्टिकल, मॉलिक्यूल अपनी प्लेस पे नहीं होता है, या किसी एटम, पार्टिकल या मॉलिक्यूल की डुप्लीकेसी हो जाती है, देन अगेन इट इज डिफेक्ट. सो नाउ we'll talk about defects. So generally defects are of two types. One is point defect and other is line defect. First one is point defect and the second one is line defect. Now what is point defect? अगर किसी भी क्रिस्टलाइन सॉलिड में एक एटम, एक पार्टिकल, एक आयन की वजह से कोई डिफेक्ट हो रहा है, उसकी डुप्लीकेसी हो रही है, उसकी मिसिंग हो रही है, तो उसको अपन कहेंगे पॉइंट. बिकॉज एटम, पार्टिकल, मॉलिक्यूल्स आर कंसीडर्ड एज पॉइंट्स हियर, सो सच अ डिफेक्ट इज नोन एज पॉइंट डिफेक्ट. लेकिन अगर रेगुलर क्रिस्टलाइन अरेंजमेंट में पूरे का पूरा हॉरिजॉन्टल, वर्टिकल या कोई भी रो गायब हो जाता है, then it is known as line defect. तो कंप्लीट रोज में अगर डिफेक्ट अराइज होता है, then it is known as line defect. लेकिन अगर एक एटम और पार्टिकल की वजह से कोई डिफेक्ट अराइज होता है, then it is known as point defect. And this is not in our syllabus. Line defect is not in our syllabus. Only our syllabus includes point defect. तो आगे जो अपन स्टडी करेंगे, that is about point defects. ठीक है. और ऐसा माना जाता है कि at perfectly 0 डिग्री सेंटीग्रेड every solid is perfectly crystalline solid. जैसे जैसे टेम्परेचर अराइज होता है, वैसे वैसे एटम्स, पार्टिकल्स, आयंस जो है वो अपनी पोजीशन से डेविएट करते हैं. तो वी कैन से एज द टेम्परेचर इंक्रीजेस, डिफेक्ट्स अराइजेस. सो विल टॉक अबाउट पॉइंट डिफेक्ट्स. सो पॉइंट डिफेक्ट इज अगेन divided into 3 types. Number 1 is stoichiometric defects. Second one is non-stoichiometric defects. And third one is impurity defect. Third one is impurity defect. So point defect is divided into 3 categories: stoichiometric defect, non-stoichiometric defect, and impurity defect. First of all, we'll go with stoichiometric defect. Now, first of all, what is the stoichiometry? Now, let us see a compound AB, or we can say example NaCl. Here, what is the stoichiometry of this compound? The ratio of cation and anion is 1:1 here. If the ratio of cation and anion remains same, before and after the defect, then it is known as stoichiometric defect. अगर कटायन और अनायन का रेशियो जो डिफेक्ट से पहले था वही डिफेक्ट के बाद में रहता है, यानी कोई केमिकल चेंजेस नहीं होते हैं उसमें, कटायन और अनायन का रेशियो सेम रहता है, then it is known as stoichiometric defect. लेकिन if the ratio changes, then it is non-stoichiometric defect. क्या हो जाएगा वो? Non-stoichiometric defect. For example, अगर अपन माने the formula of compound is zinc oxide. After defect, it becomes zinc 1.20. Earlier the ratio is 1:1. Now the ratio is 1.2:1. So such type of defects are known as non-stoichiometric defects, in which the ratio of cation and anions differs after the defect. And if the ratio remains same, it is stoichiometric defect. And about impurity defect, we'll talk later on. So first of all, we'll talk about stoichiometric defect. So stoichiometric defect is the defect in which the cation anion ratio is same before and after the defect. There is no change in the ratio of cation and anion, then it is known as stoichiometric defect. Now this defect is again of 4 types. First is vacancy defect. Second is interstitial defect. Third one is Schottky defect. Fourth one is Frankel defect. First one is vacancy defect. Second one is interstitial defect. Third one is Schottky defect. Fourth one is Frankel defect. So these 2 types of defects, vacancy and interstitial defects, these are present in non-ionic solids. These are present in non-ionic solids, whereas these 2 defects are present in ionic solids. So the 2 defects, vacancy and interstitial, are present in non-ionic solids, whereas the 2 defects, Schottky and Frankel, are present in ionic solids. So we'll consider one by one. So first of all, we'll start with vacancy defect. Let us consider any crystalline solid. This is non-ionic solids. So we'll write AA here, no ion is there. Now in vacancy defect, any atom or particle is not present at its lattice site, or we can say is missing from its lattice site, leaving behind vacancy. कोई भी एटम और पार्टिकल अपनी जगह पे नहीं होगा और उसकी जगह पे क्या होगी? वैकेंसी. Then it is known as vacancy defect. वैकेंसी का मतलब क्या होता है? खाली. तो यहाँ पे क्या हो गया? इसकी स्पेस क्या हो गई? खाली हो गई. तो ये डिफेक्ट क्या हो गया? वैकेंसी डिफेक्ट हो गया. एंड सच डिफेक्ट्स डिक्रीजेस द डेंसिटी. ये किसी भी नॉन आयनिक सॉलिड की डेंसिटी को क्या कर देंगे? डिक्रीज कर देंगे. क्यों कर देंगे डिक्रीज? बिकॉज एटम्स और पार्टिकल्स आर नॉट प्रेजेंट एट देयर साइट. So their sites are vacant, उनकी साइट्स खाली रहेंगी, तो जिसकी वजह से डिफेक्ट अराइज हो गया और इसकी डेंसिटी क्या हो गई? डिक्रीज हो गई. एंड सच डिफेक्ट्स अराइजेस व्हेन सॉलिड्स आर हीटेड. जब भी अपन किसी सॉलिड को हीट करते हैं तो इस तरह के डिफेक्ट्स जो है वो अराइज होते हैं. So first one is vacancy defect. In vacancy defect, atoms and particles are not present at their lattice site. They are missing from their lattice sites and there is vacancy behind them. So such defects are known as vacancy defect. They decreases density and arises when a solid is heated. जब एक solid को heat करते हैं, then such type of defects arises. Second one is interstitial defect. Interstitial defect. Now, what are interstitial sites? This is any solid the vacant sites, these positions, these are known as interstitial sites. So in this defect, extra atom or particle is present at interstitial site. इस डिफेक्ट में कोई एक्स्ट्रा एटम और पार्टिकल कहां प्रेजेंट होगा? इस गैप में प्रेजेंट होगा. सो सच डिफेक्ट्स, interstitial defects increases the density of a particular solid. ये डिफेक्ट किसी भी सॉलिड की डेंसिटी को इंक्रीज करते हैं. बाय बिकॉज एक्स्ट्रा पार्टिकल्स, एक्स्ट्रा एटम्स आर प्रेजेंट इन द interstitial site. Now these defects, vacancy and interstitial defects are present in non-ionic solids. Now we go for other types of stoichiometric defects which are present in ionic solids. So next one is Frankel and Schottky defect. Frankel and Schottky defect. So first of all, we'll talk about Frankel defect. This defect is present where there is large difference in the sizes of cation and anion in an ionic solid. ये डिफेक्ट उन आयनिक सॉलिड्स में प्रेजेंट होगा जहां पे कटायन और अनायन की साइज में लार्ज डिफरेंस होता है. फॉर एग्जाम्पल, विल कंसिडर वन एग्जाम्पल ऑफ जिंक सल्फाइड. This is a crystalline solid, ionic solid, Zn plus 2, sulfur minus 2, Zn plus 2, sulfur minus 2, Zn plus 2, sulfur minus 2, Zn plus 2, sulfur minus 2. This will go in the similar manner. Here, the smaller ion, among cation and anion, which one is smaller? Cation. We have already studied in lower classes that cations are always smaller than their isolated atoms, whereas anions are always larger than their isolated atoms. So the smaller ion, that is cation, is dislocated from its position and occupies interstitial site. क्या होता है? जो छोटा आयन है वो अपनी पोजीशन को छोड़कर और कहां आ जाता है? इंटरस्टिशियल साइट में आ जाता है. So there is a kind of dislocation. यहाँ पे क्या होता है? डिसलोकेशन होता है. And we can say this is a sum total of vacancy and interstitial defect. क्यों? क्योंकि यहाँ पे तो वैकेंसी हो गई और यहाँ पे क्या हो गया? इंटरस्टिशियल डिफेक्ट हो गया. ठीक है? So in this defect, first of all, this defect is present where there is large difference in the sizes of cation and anion. Second point is the smaller ion, that is cation, is dislocated. It's located from its normal position and occupies interstitial site. And in this defect, there is no change in the density. No change in density. Why there is no change in density? Because जिंक प्लस 2 जो है उसने अपनी लैटिस साइट छोड़ी है, क्रिस्टल से बाहर नहीं गया है. लैटिस साइट छोड़कर कहां आ गया है? वो इंटरस्टिशियल साइट में आ गया है. So that's why there is no change in the density of a particular ionic solid, this type of ionic solid. In case of Frankel defect, the density remains unchanged. So there are three main points of this defect. First one is this defect is present where there is large difference in the sizes of cation and anion. Second is in this defect, the smaller ion, that is cation, is dislocated from its normal position and occupies interstitial site. And third point is there is no change in the density of a particular solid in case of this defect. And the main examples of this defect is silver salts and zinc salts, zinc oxide, zinc sulfide, silver chloride, silver bromide, because in these cases the cations have smaller sizes. So now we'll go for Schottky defect. Schottky defect is present where in the ionic solids where the size of cation and anion is approximately same. ये डिफेक्ट वहां प्रेजेंट होता है जहां cations और anions की साइज जो होती है वो अप्रोक्सीमेटली क्या होती है? सेम होती है. And in this defect, equal number of cations and anions are missing from their normal lattice site. Now what does it mean? For example, NaCl का example लिया अपन ने. NaCl, will write them alternatively. So in this defect, if once sodium plus ion lifts its position, then the crystal becomes negatively charged. So to maintain the electrical neutrality, one chloride is also missing from its normal lattice site. अगर एक आयन निकला है क्रिस्टल से बाहर तो उसके साथ में दूसरा आयन भी निकलेगा to maintain the electrical neutrality. So in this defect there is change in the density. The density decreases. Density क्या हो जाएगी यहाँ पे? Decrease हो जाएगी. क्यों? क्योंकि क्रिस्टल आयन्स जो है वो क्रिस्टल से बाहर जा रहे हैं. So the main difference between these two is, first one is this is present in the ionic solids where cation and anion size, there's large difference in the sizes of cation and anion. This is present where cations and anions have approximately same sizes. In this defect, the smaller ion is dislocated from its normal position and occupies interstitial site. In this defect, equal number of cations and anions are missing from their positions. In this defect, there is no change in density. In this defect, density decreases. And this is present in alkali metal halides. For example, NaCl, KCl, this defect is present there. Because alkali metal ions are comparatively larger in sizes. That's why this defect is present here. Now, if I ask why alkali metal halides will not show Frankel defect. Why they do not show Frankel defect? Because the sizes of alkali metal ions is large enough to fit into the crystal, fit into the interstitial site. Size उनका बड़ा होता है, तो वो interstitial site में fit नहीं हो सकते. इसलिए alkali metal halides जो है वो Frankel defects जो है वो show नहीं करते हैं. They show Schottky defect. So this is all about stoichiometric defect. One more thing is there. यहाँ पे अपन देखेंगे equal number of cation and ion is missing from their normal lattice site. So both equal number में cation जितना गया उतना anion गया. So stoichiometry remains same. जो रेशियो था cation and ion का उसमें कोई फर्क नहीं पड़ा. क्यों? एक सोडियम गया, एक क्लोरीन गया, दो सोडियम गए, दो क्लोरीन गए, तो रेशियो रिमेन सेम. और यहाँ पे कोई बाहर ही नहीं गया, क्रिस्टल में ही है, तो cation and ion का रेशियो जो है वो क्या रहेगा? सेम रहेगा. कोई जो है केमिकल चेंज जो है यहाँ पे reaction, chemical reaction जो है, it will not take place in these cases. So we can say these defects comes under the category of stoichiometric defect. The stoichiometry remains same before and after the defect. So we'll revise. Stoichiometric defect, we'll divide it into four types: vacancy, interstitial, Frankel, and Schottky. Vacancy and interstitial defects are present in non-ionic solids, whereas Frankel and Schottky defect are present in ionic solids. Next, we'll go for third type of defect first, impurity defect. Non-stoichiometric defect is quite larger, so we'll talk tomorrow about that. Next is impurity defect. Let us take an example, sodium chloride, once again. This is a crystal of sodium chloride, Na plus Cl minus, Na plus Cl minus, plus Cl minus, Na plus Cl minus. In this defect, we add a slight amount of strontium chloride as an impurity. NaCl का क्रिस्टल है अपने पास में और अपन ने उसमें क्या ऐड कर दिया? We added some strontium chloride into it. ठीक है? Which acts as impurity. So जब अपन ने सोडियम क्लोराइड में strontium chloride मिक्स किया, तो some chlorine is same. Some of the strontium ion replaces sodium ions. Strontium सोडियम को रिप्लेस करेगा. अब मान लीजिए यहाँ पे strontium आ गया. अब strontium के ऊपर चार्ज क्या है? +2. Now the crystal becomes charged. So to maintain the electrical neutrality, one sodium ion is missing from its normal lattice site. Electrical neutrality को maintain करने के लिए एक सोडियम आयन भी अपनी पोजीशन से हट जाएगा. तो such type of defect हो गया, वो हो गया, vacancy हो गई. So such type of defect is known as vacancy defect. We can say each strontium replaces two sodium ion and occupies the position of one, leaving behind cationic vacancies. Leaving behind cationic vacancies. हर सोडियम, हर स्ट्रोंशियम आयन दो सोडियम को हटाएगा, एक की जगह खुद आ जाएगा और एक की जगह क्या क्रिएट कर देगा? cationic वैकेंसी क्रिएट कर देगा. So such defect is known as impurity defect. Why? Because the crystal is of sodium chloride and strontium chloride is added as an impurity here. Strontium chloride is added as an impurity here. Same defect is observed when AgCl is added with cadmium chloride. जब अपन सिल्वर क्लोराइड में कैडमियम क्लोराइड डालेंगे तब भी अपने को सेम टाइप का डिफेक्ट जो है वो मिलेगा. So this is second type of defect, impurity defect. Now one defect is left, that is non-stoichiometric defect. That is quite larger. So we'll talk about that defect tomorrow. So that's all for today. I'll provide you notes on your WhatsApp group. So read it carefully, study it carefully, and if you face any problem, talk to me. Thank you.